Hi class, new chapter, new day. This chapter 7 will be a lot of proportions, setting them up and solving them. So make sure that you understand this first section and how to solve things because we'll just be building from here. A little review from previous math classes. A ratio is a comparison between two numbers or quantities. So let's just write comparison between numbers. And it'll be important that you make sure you pay attention to how that ratio should be. So I'll just write down that the order that you write it in is important. And as we do some of the examples, I think you'll see why. There's three different ways to write a ratio. The first way is you could write A to B, and you could have A and B just be your numbers. So it might be like 5 to 7 or 8 to 2. And that's the first way to write it. The other two ways, you read them as A to B, but it could be written with a colon, or it could be written basically like a fraction. But all of these ratios, if you were reading them, you would read it as A to B. This next one for you baseball players out there, a baseball example says the batting average is the ratio of the number of base hits to the number of at-bats. So the ratio is base hits to at-bats, not including walks. And then it says Minnesota Twins, Joe Mauger had the highest batting average in Major League Baseball in 2006. He had 521 official at-bats and 181 hits. Find his batting average. So what I want to do here is I want to make sure I give the ratio of base hits, which was 181, and then give that to the number of times at-bat, so 521. So you could write it this way, or you could write it with the word to, or you could write it kind of like a fraction. It wouldn't really matter. But one thing you do want to do is always simplify these. And because this is a batting average, the way that they usually have those written is as a unit ratio, where you say it's so many to 1. So what you could do here is actually just divide those numbers, and you will have to round this. It's approximately 0.347, and that's to 1 if you write it as a unit ratio. Most of the ones we're going to be doing we won't write as unit ratios, but it is important for this because that's how they give batting averages. And you'll also see this a lot like in the grocery store. If you're looking at like the price per ounce or the price per pound of things, it always says that on the little tag. But it'll be like per 1 ounce or for 1 pound or for 1 unit or whatever the situation may be. So some new ratio work that you probably haven't done before. An extended ratio will just compare 3 or more quantities. And the way that you'll see these written is you might have like A to B to C. Most of the ones we're going to do are just going to be 3 of them because we're going to be looking at these examples a lot with triangles, but they could be for, you know, different quadrilaterals also. Then you would just have a 4th one on there. So this first example here, it says the ratio of the measure of the angles in a triangle is 5 to 12 to 13. Find the measure of those angles. So what that means is that if you divide all of these angles by some multiplier, you're going to have a ratio of 5 to 12 to 13. So hopefully you know that this doesn't mean that this is 5 degrees and this is 12 and this is 13, because those wouldn't add up to equal the 180 degrees that a triangle should have for the angles. What it means is when you divide all of those angles, that's your ratio like after it's been simplified. So what you can do is you can say, okay, I'm going to multiply 5 times some multiplier, 12 times the same multiplier, and 13 times the same multiplier, and that's going to be how you get this extended ratio. So what you're going to do here is you're just going to pretend like you need to solve for x, figure out what you're multiplying each of those by, and since all of those interior angles add up to 180, you can just set it up that way. So when you add all those up, let's see, that's going to be 30x equal to 180, or when you divide, x is going to equal 6. And then the question says, find the measure of the angles. So it's not good enough just to solve that and say that x is 6. We actually want to take that and plug it back in. So when you plug that back in, you would have this angle here, 5 times 6 is 30 degrees. For this one here, 12 times 6, that's 72 degrees. And for this one here, you should get 78 degrees. So again, if you were to take those and divide them each by 6, you would get back to this ratio, and that helps you answer that question. For the next one, it's kind of set up the same way, except now it's talking about the measure of the sides, and this is your ratio for the sides. For when they give you the sides, they also have to give you the perimeter, because that can vary. And because the ratio is 2 to 2 to 3, I actually know that this is an isosceles triangle, and those sides are not actually 2, 2, and 3, because that adds up to be a far cry from the 392 that it has to be. But if I think about what do I need to multiply each of those by, I can basically do the same thing where I'm just adding up all those sides, but now we're talking about the perimeter, so I would set that equal to 392. So when I add all those up, I get 7x equals 392, and I'm going to need to grab a calculator here. So 392 divided by 7 is 56. So x equals 56, and again, it's not asking me to find x, it asked me to find the length of the longest side. So the longest side would be this one here. So I can then just take that and multiply it by 3. And then this longest side would be 168. If it did ask you for those other sides, then you could take those and plug them in for that. But here it's only asking for the longest one. And I would include some units on there, 168 inches, and then that one would be done. So a proportion is when you have two equal ratios, and I know in algebra you did some work solving proportions. When we're solving proportions, what you're going to be doing is you're going to be cross multiplying to solve. And I'll just kind of write it out in general terms here. If I have A over B equals C over D, these two numbers in these two spots are called your means. And these other two numbers are your extremes. And what you end up doing is you multiply the extremes and you multiply the means, you multiply across, and then those are equivalent also. So I could say that A times D is equal to B times C. And then you could go through and just solve for whatever you need to. So for example, for these proportions here, I would multiply x times negative 6, so negative 6x. And I would multiply 4 times 11, so that's going to equal 44. And then when I go through and divide this, some of these you will end up with either decimals or fractions depending on how you want to write them. I'm just going to leave them as fractions, so I could simplify each of those by just dividing by 2. So it'd be negative 22 over 3. If you'd rather make that negative 7 1/3 or negative 7.3 repeating, if that's more comfortable for you to leave it like that. It doesn't really matter to me how you want to write that. For this next one, when you cross multiply, you have a little bit of an issue because you have this whole quantity. You need to make sure that you multiply that whole quantity by the -4, so think distributive property for this. So -4 times 2y is -8y, and -4 times 5 is -20, and that's going to be equal to 7 times 6, which is 42. And then you can go through and just finish solving that. So you have -8y equal to 62, and then when you divide them each by -8, again, this doesn't divide evenly, so if you want to just leave this as a fraction, you could. You can divide each of those by 2, so that'll be -31/4, or if you'd rather change that, let's see, that's going to be -7.75, or -7 3/4 if you'd rather write it that way. For this last one, when I cross multiply here, I got to distribute the 7 to these quantities. So that's going to be 7z plus 28. And then I'm going to multiply the 9 by both of those terms. So 9z minus 9. And then go through and solve for z. Hopefully we're just good at this by now. When I go through and solve this, I have 2z, and let's see, that's going to be 37, and then I'm going to go through and divide each of those by 2. So again, it's a personal preference here if you want to just leave it. You could say that z equals 37 halves. If you'd rather change that, that's going to be positive 18.5, if you'd rather write it that way. So then kind of the whole goal of this is getting to where you can set up your own proportion and then solve it. Like in this example here, it says, in an experiment, students netted butterflies, recorded the number of tags on their wings, and then released them. So the students netted 48 butterflies, and 3 of those had tagged wings. So what I can do is I can write the ratio of the butterflies to the number of ones that had tagged wings. So if I'm going to set my ratio up like that, my first part is going to be 48 to 3. So 3 out of 48 had tags. Here it says predict the number of butterflies that would have tagged wings out of 100 netted. So the important part of this is that you get that 100 in the right spot, so that when you solve this, you're going to get the right answer. So the 100 butterflies netted would be my part that I put in the numerator of my ratio. So I would put the 100 here, and I want to know how many are tagged. So call it T for tagged or X or whatever variable you want. You could set it up like this. So when you cross multiply, you get 48T equal to, this would be 300. So when you divide, when you're solving, dividing each side by 48, you're actually going to end up with a decimal for this. Just grab the calculator again. So we have 300 divided by 48. It's 6.25, but that doesn't really make sense in terms of our story problem. So when it says like to predict the number of butterflies, you would say about 6 butterflies. And this is just an approximation. Obviously, for like real life experiments like this, it might be more, it might be less. This is just a prediction if you kept seeing that same ratio, what it would be. And then the last thing I want to point out, you'll probably hear me say this in class over and over and over again, but there is definitely more than one correct way to write a proportion. What you want to check and see is that you have things lined up properly. So because I just chose to put like the butterfly number in the numerator here, I'd have to get that lined up with the other number that represented butterflies there. And because I had the number of tagged butterflies, then I'd have to line that up with the number that were tagged down there. But there are definitely more than one way, and this down here kind of illustrates it for you. All of these ratios would be equivalent, and the easiest way to tell if they're equivalent is if you're cross multiplying the same numbers, you're going to get the same answer. So you can see here I'm multiplying B and C together. Here I'm also multiplying B and C together. Here it's B and C multiplied, and there it's B and C multiplied together also. So even though like the way I might write mine might be different than yours, as long as we're getting the same answer, it's okay. But that doesn't mean you can set up any way you want. Like for this one here, I could not say 48 is to 3 and then put like the number of tagged over 100, because then I wouldn't be cross multiplying the same things. That would get me the wrong answer. So just be careful, and if you have questions on how to set this up, I'd be more than willing to help you. I actually look forward to helping you guys as you work on it.